Hello, I'm Jason Broderick Pearce and welcome to Engineering Resilience. This isn't really a story about an airport today, despite the title in the Part 1 article. It's more about what happens when redundancy isn't actually resilience. And the key question to follow as we look at this today is, how can one weather event remove a critical operational function? So I was recently travelling from Aberdeen down to Bristol with a client to see a second facility, and I was on board the aircraft, only a small aircraft, about 9 of us on board, and the flight attendant notified us about 30 minutes before we were due to land in Bristol that the flight had been diverted to Cardiff. Now, that was all that was really told at the time, and due to the nature of my job and the nature of me as a person, I inquired further. So what is the problem in Bristol? And she replied that a thunderstorm, a large electrical thunderstorm, had passed the airport, and they had lost air traffic control function. So I didn't really have any other questions to ask at that point, because obviously that was quite a surprising response to me. So anyway, we arrived in Cardiff, and luckily we were one of the earlier aircraft, as several others had been diverted through into Cardiff, larger aircraft as well, EasyJet, because the whole of Bristol actually lost operation. And we quickly hot-footed across to Cardiff in a taxi. This was on June the 22nd of this year, which was the beginning of all of the travel chaos in the country due to the hot weather we'd had. And obviously, as a passenger, it was an inconvenience having to get a taxi across to Cardiff. But as a loss prevention engineer, I couldn't really stop thinking about what had actually happened there. Why did the operational barriers not preserve the service? Air traffic control is a protected service. It's protected infrastructure, critical infrastructure, and should usually be the last thing to be lost, and there should be secondary systems in place, resilient secondary systems. So why that matters? If we don't stop at the initiating event. So for me, a thunderstorm passing the airport, no matter how severe in this country, for me, shouldn't have been capable of removing that service. And we need to follow really the pathway from that event through any dependencies and to the loss of the function. Because the backup only really matters if it remains available at the moment that the primary is lost. Redundancy, the key kind of distinction here is that redundancy doesn't equal resilience. And a great example I like to use is generators, backup generators in facilities. So a lot of facilities will have a secondary generator, and when asked why, obviously it's just because in case the first one breaks down. So that's great, but that's only one mode of failure. And actually, yes, in which case, looking at it from that angle, it is resilient in that respect. If you're looking at it purely from a mechanical breakdown perspective, a secondary backup generator fulfills that need for resilience in that respect. However, for example, if there's a mechanical failure in one and there's a loss of service, but it was an overheating bearing and some oil sets on fire, and then you get a diesel pull fire and you lose the second generator, that clearly wasn't resilient against fire events, and it wouldn't be resilient against many other events due to the interdependent nature in the room, even especially in the absence of fixed fire protection, special protection systems. So two systems may look separate, but they might share power, they might share routing, location, antennas, cyber infrastructure, software configurations, even environmental controls, clean room type places. The loss of one area can significantly impact the other, and it may not be immediately obvious until we've followed that through. And it can even apply to people or suppliers. So the key test really is, can our backup fail for exactly the same reason as the primary? The real objective is to understand behaviour on the system's worst day. So on its very worst day, we call it maximum foreseeable loss, and that's usually when everything fails, everything that could possibly fail fails. What's the worst that can happen? And that's what we need to be looking at for it to be truly resilient. What we find is that the starting point in conversations is always when we go in to do full-scale kind of audits at the beginning of a relationship is well, we comply with this, and we comply with this law, and we comply with this standard. But standards and maintenance checks and that kind of stuff should only ever be the starting point. The real objective is to understand the behaviour on the system's worst day, and standards aren't generally there to look for that kind of dependence. They're looking for compliance with making sure that things don't impact human beings directly, rather than the greater business. So, counting backups is really easy. Mapping hidden shared dependencies in the real world, that's the resilience work. It applies to everything. So the three practical takeaways from this really are: you start by mapping, trace every dependency required to preserve that critical service, and then challenge. We need to test credible scenarios like those MFLs. And common cause is not just single equipment failures. We're looking at how the system behaves as a whole, not as an isolated part. And then prove, so verify that separation. Validate the response times. For example, an electrical switchover, it has to be fast. Manual fallback. Make sure whoever is responsible for controlling these events knows who they are and they're well trained. So really, Bristol Airport, that was just got me thinking. That was a perfect example of, I think, just where to start, where redundancy isn't necessarily resilience. Because while we don't know what happened yet, we do know that both primary and secondary air traffic control functions were lost, which certainly seems like there's a resilience issue there. So the final question is, where in your organisation might two independent systems actually share the same fate. And I won't say much more than that. Ask me, you're more than welcome to ask. But the closing lesson really from part 1 of this series is every major incident leaves lessons. Now, the strongest organisations learn the fastest, and as soon as a lesson is learnt by one, they'll adopt the mitigation strategies to ensure that their organisation doesn't suffer the same. So, thank you very much for spending your time with me today, and if you have any questions at all, please do feel free to pop those in the comments. Thank you very much. I'm Jason Broderick Pearce, your host for Engineering Resilience. We'll see you for part 2 next week. Goodbye.